Now see here, I'm going to design the impedance matching network. I'm finding out all the reflection coefficient. You have four gammas. Gamma S is the reflection coefficient of impedance matching network. Gamma in is the reflection coefficient of your amplifier input. Gamma out, reflection coefficient of the amplifier output, and gamma L is the reflection coefficient of your load. So I'm defining all the gammas, calculate the gamma L, gamma S of the amplifier, and I'm going to plot that in Smith chart. Even Smith chart is available in MATLAB. See here, you will be seeing a beautiful Smith chart after the end of this. You're able to see the beautiful Smith chart which is available inside MATLAB. So it is showing the reflection coefficient of ML and MS. ML is load and MS is source. So we are bothered. I told you these impedance matching networks will work only at a one particular frequency. So I am going to design the network at the frequency 1.9 gigahertz. I am extracting the value of frequency and gamma L at 1.9 gigahertz. Okay, I am extracting that particular value. Okay, what is the frequency and what is the reflection coefficient value? I am extracting from that Smith chart object. Once that is done, I'm going to plot and I'm going to see. I'm going to draw the matching circles. I am assuming that this matching is already the basics of transmission lines. Match and transmission lines, you would be studying all these matchings. You are drawing a matching circle. See here, this is the matching circle, and you know the center of Smith chart is given by the point 1. Always center of Smith chart is going to be a stable point. So wherever your circle is there, whichever area contains this one point, everything is going to be stable. And this complete area inside the circle is going to be stable. Now we are going to draw the one circle and find the point of intersection. See here, we are drawing this red circle and I am finding the point of intersection. Once I find the point of intersection, I can find the coordinates and I can go for impedance matching. Okay, so this is a step-by-step process. And this, again, the stub, everything, the single stub matching and other things are given here. I'm just running it one by one. Same way, I'm calculating the value here. This is coming from the previous thing, right? So it is having some issues in there. That is not an issue. Just understand that even whatever complex thing which we have been doing manually for a long time, everything has been simplified with MATLAB. So Smith charts, we would have been drawing Smith charts with a lot of errors in our UG classes. But here you can get everything in a single stroke. Okay? So we have seen today about the super heterodyne receiver. We have seen band pass filter, design of band pass filter, how to verify the answer for a band pass filter, and we have seen how to draw the stability circles for a transistor amplifier.